Howdy, howdy. Hope everybody's having a good day. We are live. Welcome, welcome everybody. Hope everybody's having a good day. I know I'm not, and I only say that because I did not sleep well. I did not sleep enough or well. Are you a monist or pluralist in terms of your ontology? I don't have a settled position on that. Like, it could be, yeah, the cat's been insufferable. I could be a monist, but I'm open to, you know, I'm open to being a pluralist about that. Sorry, I just have to take care of something on my phone. Oh, this is so annoying. Do you have a kitty cat to cuddle? I do. Yeah, she's awful. Howdy, howdy. Oh my god, just let me schedule my delivery, please. 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 Add new address. Do you believe dark energy exists or multiversal medium pole? I think that dark energy exists. Today is fine. Can we use electric charges to make a monopole magnet? No, we can't. Unfortunately, we cannot. Sorry, give me one moment. I just got a text message about having to schedule a medication delivery, which is annoying. And so that's what I'm doing right now. And then I will be perfectly available to answer all of the questions. Okay. Continue. Okay, finally it's done. All right, sorry about that. Have you played Outer Wilds? I have not. I have not. When playing Tug of War, is it better to have a heavier people in the front or back? It shouldn't really matter. Do all your fan club stuff and accept your points. Yeah, there you go. Have you ever tried to make a monopole magnet? Well, you can't. At least not according to all known laws of physics. Can gravity be explained quantum mechanically? Hopefully, but not, we don't know how yet. Sorry, let me lower this just a smidge. Or raise it? There we go. How many Halloweens have you dressed as Egon Spangler? None. Can you briefly explain which path information destruction? Oh yeah, so the point is that, you can get which path information by doing an entanglement where one path entangles with one outcome and another path entangles with another outcome. But if those two outcomes are then combined, then you no longer have a way to distinguish between which path. How are you? How's the surgery? When will how's the procedure? The surgery already happened. The surgery happened 2 months ago. You're a little bit behind. Go watch the video from, I don't know, the beginning of April. All the update is there. Do you plan to stream Subnautica 2? I don't know. Do you think we can interact with other worlds in many worlds interpretation? No, kind of by definition. The worlds are by definition uninteractable. What was the basis of your quantum gravity research? Well, I kind of went over it in the video, but the idea was using something called quantum Riemannian geometry, which is a different approach to quantum gravity that isn't one of the main three, or one of the main two, string theory or loop quantum gravity. It's a different approach. It uses something called it uses these things called quantum groups or quantum algebras. And so we just basically tried to implement that to try to say something about the physical world. Are there alternatives to Cavendish, like a trapped particle to measure gravity? Yeah, there are. It's just Cavendish is the most straightforward, the most simple. What we like, for example, one thing that we can do is we can measure the gravitational or the eigenstates produced by a gravitational field for like a single particle trapped in a well. Do you seriously subscribe to Poincare recurrence? Poincare recurrence is a mathematical fact, and so it's a thing that absolutely will happen so long as the conditions are met. What is mathematical physics? Think of it as like the deranged love child of mathematics and physics. So you have the intuitions perhaps of a physicist, but the methods you use are those of a mathematician. You should create a Patreon and react to pop culture movie shows and dissect them from a physicist perspective. I already have a Patreon, but I'm not going to lock any content behind paywalls. I'm not going to make it so that you can't watch this if you don't pay. But I also don't have enough time to add an additional kind of content. Is the singularity too small for omnidirectional gravity input? I don't know what the question means. When are you playing KSP again? Probably on the weekend. I'm a bit concerned with PhD program funding. Any advice for an aspiring graduate student? It's a reasonable thing to be concerned about. I don't have any advice because I'm not in the scenario that you're in. When you're applying for grad school, if you decide to apply for grad school, make sure that you get in writing that you have guaranteed funding for X many years. Do you do any mathematical style proofs in your research, or is it mostly database calculation? Oh, no, I do genuine mathematical proofs. Why do physicists consider space-time to be a single entity when space and time behave differently? Well, they behave differently, but in a unified way. In the same way that like electromagnetism is one thing, but electricity and magnetism do behave differently. If many worlds exist in a Hilbert space and they're orthogonal, then why can't we go to another world? Because they're orthogonal. We are in one orthogonal. Oh, like you can think of it as a single wave function, but the wave function, so let me put it this way. The wave function evolves linearly, which means that the eigenvalues, the coefficients for the eigenvalues don't talk to each other. How long did it take to get my PhD? Straight from undergrad, it was 7 years until I finished my PhD. Is intuition a big part of being a physicist? Yeah, I think so. Thoughts on remote viewing? I'm not convinced. Skog, you got into grad school. Congrats. What's the theory we are most unsure about in astrophysics or quantum physics? A theory we're most unsure about? Well, there's a whole bunch of like models and stuff that just have very little supporting evidence. So all of those. Is the boundary functional completely blind to specific metric choices? If you're talking about the boundary functional in like the Gibbons-Hawking-York term, yeah, that's, well, okay. The idea there is that you want the, it is agnostic to those. Where do PhDs in mathematical physics work other than college teacher? Well, the word you're looking for is professor, but the thing is you get if you get a PhD in mathematical physics and then you go do something else, like if you go get hired in finance, or if you go get hired at a startup, or if you go work at some, whatever, then you're just not doing that thing anymore. I'm gonna jump down to the bottom because I'm quite a bit behind. Apologies for that if I missed your question. What is the Van Allen belt and why do flat earthers say it prevents us from space travel? So the Van Allen belt is basically like a donut, or rather it's a pair of donuts wrapped around the Earth. And In those donuts, they're roughly the shape of the Earth's magnetic field. In those donuts are charged particles. The Earth gets a lot of charged particles from the sun and from interstellar space. We would call these cosmic rays, but the Earth's magnetic field traps them there. And so as a consequence of being trapped there, there's just a high density of those charged particles, which are radiation in those areas. And so if you hang out in those areas, you will get a high radiation dose. Now, it doesn't prevent us from space travel. You just have to pass through them quickly. How can the wave function t equals 0 be interpreted as the formula is eternal, meaning it isn't reliant on time, but just not timeless, just eternal? I don't know what that question means. Where do you think iron came from? Like, was it from the ground or from the asteroids? Well, most of the iron comprising the Earth formed with the Earth, like it came with the Earth. But a lot of the surface, I don't know about a lot, but some of the surface iron came from meteors. How close can you have an enclosed system in a vacuum chamber with nothing in between them? I don't understand the question. How does inhomogeneous dark energy affect structure growth and observables, and which models remain constant with local gravity tests? I'm not sure. I'm not familiar with any dark energy models that are inhomogeneous. So I can't evaluate that. Most dark energy models, as far as I know, are fairly homogeneous, or at least they're homogeneous at small scales. How do Everettians respond to the preferred basis problem? In one basis, there are infinite branches. In another basis, there are finite branches. Well, the branches are not meaningful, right? At least that's my view. The branches are kind of just like a way of talking about things. It's not like it's not a thing that has a physical ontology. Do you ever visually imagine GR and QFT concepts, or do you think about them purely through a math and physics lens? I do visually imagine GR. Yeah, both actually. I visually imagine both of them, but it's more of like a conceptual thing and not necessarily a explicit thing. Foot Punch, welcome to the Dr. Blitz Debunks membership. Thanks for being here. Thanks for your support. Were you bullied in school? I mean, there was a bully in school, if that's what you mean. But sure, yeah. By like one guy. Is it very hard nowadays to obtain a job with a physics degree? I don't know. I mean, it's hard to get a job in academia, but that's been the case always. If two tiny masses are each placed into quantum superpositions and only interact between them is gravity, how could they become entangled? Well, that's one of the questions that we're hoping quantum gravity can solve. Why do they say meters per second? Because that's a way of describing acceleration. It's telling you how quickly the meters per second changes. Do you regret your degree? No, not in the slightest. Any recommendations for a book on math? I'm at the limits of my understanding, but want to be able to engage better in it really depends on what level you're at. Is Gauss's law in any closed system, the electric and magnetic fields are zero? No, you can have electric fields. No, okay, I see what the question is. No, so the point is Gauss's law says that there are no Gauss's law says that there are no magnetic charges, and the electric field produced by an electric charge is related to the amount of electric field. Sorry. What's the best way to explain this? If you have an electric charge, then it produces an electric field in some way that's proportional to the amount of electric charge you have. Why do you wrongly think physicists are better than engineers? Who never said that? Why are we in a massive void? It's not clear that we are. Does the Jennebekoff effect only apply to planetary objects? Yes, it does. Will we ever solve the measurement problem in quantum mechanics? Yeah, sort of. I suspect so. What do you make of Boltzmann brains? I think that it's an interesting concept. I don't think that we are them. What is actually CERN's purpose aside of finding a God particle? Could you describe it to us? Would you prof your explanations will highly regard? CERN is a particle physics laboratory. Their job is to study fundamental particle physics. That's what the laboratory is meant to do. They also do a few other things, study antimatter. I think they have some condensed matters, or they have some nuclear physics stuff, but they're a particle physics lab. They do particle physics. If the whole universe is everything, then isn't it necessarily a closed system? Well, a closed system is usually defined kind of in contrast with an open system. And it really depends on how you define a closed system. If you define a closed system as a system in which, certain quantities are conserved, then if energy isn't conserved in our universe, then it's just not the case that the universe would be a closed system, right? Why do all physicists have the same haircut? They don't. You probably just don't know a lot of physicists. So the poles could swap due to that effect. The Janabekov effect isn't necessarily about the magnetic field poles swapping. And no, generally not. In order for the Janabekov effect to happen, you have to have three different, you have to have three axes along which the moment of inertia is different. And for spherical things, there are not three distinct axes. In fact, the moment of inertia tensor is homogeneous, or rather, sorry, it's isotropic for spherical bodies like planets. So like it could happen for like planet-like things if you have like, a lumpy planet that's really, really small, but it won't happen for like large planets. Who's your GOAT raw mathematician disregarding influence? Well, the thing is influence is kind of correlated with like mathematical talent. The GOAT is probably Euler. It's gotta be, right? Could there theoretically be a black hole that is infinitely big? I suspect not. What's your theory of what caused the Big Bang? I read about a lot of different ideas. I don't have one theory. I'm pretty agnostic about the actual cause. I just think that we have a lot of different ideas for it, and what the actual cause will end up being will be borne out by the data that we have. Is string theory still a popular research area among physicists? Yeah. Where'd you get your degree? I did my PhD at UC Davis. Do you have a kitty to cuddle with? Yes, I do. Can you explain how their purr can boost your health? Talk to a biologist about that. What are virtual particles? They're a mathematical trick introduced to try to kind of diagrammatize and systematize the calculations that are very involved in quantum field theory. Thoughts on the Alcubierre drive? It's a really neat thought experiment, but I don't think that it's really something that can be realized physically. Do neutrinos use quantum tunneling so that they don't react with matter? No, neutrinos don't react with matter because they don't. That's like one of the fundamental properties of neutrinos. It's not like there's a barrier that they have to get through and then they quantum tunnel through it. There just isn't a barrier for neutrinos. I have to jump down to the bottom because I'm way behind, but thank you guys so much for asking so many good questions. How does the purely spatial model giving rise to a time-like circumstance thing interact with Ian's timeless argument? It's not clear, and I've meant to talk with them about this. Is there a chance the universe is cyclical and the Big Bang is just another iteration? Maybe. So do you think virtual particles actually exist? No, they absolutely don't exist. They're mathematical artifacts. Oh, join the link is in the background. That's my bad. I should take that away. Now Higgs found what's next for LHC. Well, so right now the LHC is planning, if I remember correctly, they're planning to do basically precision Higgs measurements. How do you explain why pilots don't constantly adjust down due to curvature? So planes are designed, the way that planes are designed is that if the trim is set properly, which a pilot is going to do, they're going to set the trim so that they can maintain level flight. If the trim is set properly, if their altitude was to increase, they would nose down, and if their altitude was to decrease, they would nose up. And then there's some features that kind of damp this thing so it kind of levels out. But the point is this is something that you could just not touch the plane at all. You don't even need a computer to be running this. This is just the aerodynamics of how planes work, that if they would be at a higher altitude, they will nose down until they get to the altitude set by the trim. And then if they get to a lower altitude, they will nose up. There's a particular name for this thing. It's a type of oscillation that I don't remember the name of. But planes, well-designed planes, fly stably at altitude. And so as the Earth curves, if they were flying straight and not curving with the Earth, then their altitude will increase. And so they'll nose down to account for that. Can we trust Ferengis? You should trust Ferengis as long as you understand them. Trust that they will do what's in their best interest. But if virtual particles don't exist, how does Hawking radiation work? Hawking radiation doesn't rely on virtual particles. It relies on quantum fields having two different vacuum states in the far past and the far future of a black hole. But a conceptual understanding of Hawking radiation can be obtained without virtual particles just as well. You can think of Hawking radiation as happening as a result of particles from the inside of the black hole tunneling to the outside. Please, can you give me the way to explain why gases exist without a barrier next to a vacuum? There is a barrier. It's a gravitational barrier. Are you worried about AI? To an extent. If virtual particles don't exist, how do particles interact with each other? Via the underlying field. We have a super chat from CM with the 10 Canuck bucks. I heard the estimated amount of stars in the universe compared to the age of the universe would mean that there would have been a crazy amount of stars created per second. How does this work? Well, the universe is big. And so if the universe was in a state, if it was, sufficiently dense that there was a very, very high density of gas kind of just hanging out, then as long as the universe is big enough, you could have however fast star formation you want. All you just need is dense gas, essentially, and it'll collapse and form stars. Is it possible that photons are eternal? They don't ever truly disappear. They're bound to recycle. Photons are not conserved. Photons can be destroyed. Photons can be created. There's no issue there. Are tachyons just a sign of a fault in a model, or is there any meaningful physics behind them? I don't think that there's meaningful physics behind them. Question, is the news about us finding dark matter legit or overblown? I haven't heard about it, so it's probably overblown. Can you explain what a mathematical brain is? A brain is just a object with some number of dimensions embedded in a higher dimensional space. That's all. If gravity is so strong it holds water to a planet, how are butterflies not affected? They are affected. That's why they fall if their wings don't flap. What's that thing inside the nucleus that has like the three letters U, U, and D that are connected? Oh, so those are quarks. There are 6 kinds of quarks. There's up and down quarks, which make up protons and neutrons. There's strange and charm quarks, which are heavier versions of the up and down quarks. And then there's top and bottom quarks, and these are even heavier still. And the quarks are bound together via something called gluons, or the strong nuclear force. You may have heard it called that way. And so in the strong nuclear force, 2 up quarks can be bound to a down quark, 2 down quarks can be bound to an up quark, and there's a whole bunch of other configurations that you can have them arranged. What's the beneficial of CERN particles project for our humankind and formalities? Is that contribute and related to human consciousness? It's not related to human consciousness. I don't know what that means. It's and personally, I value learning about how the world works, so I think that that's beneficial for humankind. Can you make a magnet, and can I do it at home? Yeah. So get a battery. Yeah, that would work. So if you get a battery and then you make a coil of wire and then you connect the coil of wire to one end of the battery and the other coil, if you connect one end of the coil of wire to one end of the battery and another end of the coil of wire to the other end of the battery, you have a rudimentary electromagnet. So particles interact via the underlying field. So if localized vibrations in those fields of the particles themselves are smaller amplitude vibrations of virtual exchange particles, it's not smaller amplitude, it's just non-particle excitation. So just the field, think of the field as having a certain shape when there's a particle, and particle excitations have certain shapes. Any other shape that the field has, that would be describable in terms of virtual particles. Is curvature necessarily uniform throughout space-time, or could regions have different curvature? Well, certainly different regions have different curvatures because there's different masses present in those different regions, right? So like near a black hole, the curvature is quite large. Near, you know, the Earth, the curvature is quite small. Where did the naming convention for quarks come from? I have no idea. Why the fuck did they give them such strange names? No idea. Physicists are whimsical, I guess. Is it true that total dark energy is weakening, and does that mean the universe is expanding slower? So it doesn't. So we don't know. This is an open question currently. There is some evidence that suggests that indeed the total dark energy is weakening. That wouldn't mean that the universe is expanding slower. What it would mean is that the acceleration rate is going down. What do you think about an idealist saying physicists can't explain what matter is? Well, I think that presupposes a substantivalist view of ontology, where a thing that, like, there is this underlying substance that's propertyless, and that properties are just things attached to that substance. Whereas a lot of physicists might just say a thing is its properties, which is bundle theory. And so if an idealist is assuming substantivalism, then they're just not engaging with a bundle theory view of ontology, which is completely compatible with physics. At the beginning of the universe, was the speed of light way faster than it is today? We don't really have any evidence that we don't have any compelling or perhaps strong evidence that the speed of light has been changing over time. When flat earthers say it's just buoyancy, can you have them state the equation for buoyancy so they have to mention little g for it to even work? It doesn't help because they don't think, like, little g is just an acceleration unit to them. Have you seen the theory of everything with the Hopf vibration? I haven't. Can you explain the physics part, how free energy is related to large deviations as a rate function? I don't understand what that question means. Don't electromagnets need a changing current? No. Nope. Inductors need a changing current. What does the equation in your other background and on your merch represent? Well, I don't have merch yet, but, and it's not one equation either. It's just a list of, it was just basically scratch work that I was working on when I was a grad student. Can you explain the Calabi-Yau manifold? Yeah, so Calabi-Yau manifolds, I actually made a video on this it actually did pretty well. A Calabi-Yau manifold is an even-dimensional hyperkähler manifold. That's what the definition is. There might be something else. I want to make sure that I don't miss something. Like, it has a fairly complicated definition. Or there's a whole bunch of different definitions that you can give, but they turn out to be equivalent. The one that I usually use is that it's an even-dimensional Einstein manifold where the holonomy is of type SUN, where n is half the dimension. So the holonomy is just basically a description of the kinds of curvature that it can have. So manifolds can have curvatures, right? A manifold is like think of it like a higher dimensional surface that can be curved in various ways. And so the way that it's curved is restricted for Calabi-Yau manifolds. It has to have, that's what the holonomy statement is about. And then when we say that it's an Einstein manifold, it's basically, there's another kind of curvature that's zero. So it's just a type of manifold that's even dimensional that has a restricted kind of curvature. Do gravitational waves from supermassive black holes have any effect whatsoever on Earth? No. I mean, we could potentially measure them, but not like any effect that you or I would notice. Gravitational waves are super, super weak. Can fish get thirsty? I don't know. What indicates that a massive star will become a neutron star or a black hole? It usually just depends on the mass and the metallicity. So how much non-hydrogen elements are in it, and then also how massive it is. What is the meaning of curvature for a finite dimensional Hilbert space? Well, look, a Hilbert space is just a vector space. It's a kind of vector space. So like you can like define a connection on a Hilbert space, I suppose. And then from that connection, you'll have curvature. Like what I'm thinking of is I'm thinking of like the tangent space for some manifold. for some Riemannian manifold, that tangent space should be a Hilbert space, unless I'm forgetting a part of the definition. Yeah, so it should be a complete metric space. So a tangent space is a complete metric space. Oh, no, I'm sorry. Yeah, it should be doable though. You just have to be careful. Why are they killing off gravitational propulsion scientists? Well, they're not. Nobody's killing them off, and they're not gravitational propulsion scientists either. Are there tangent spaces that don't preserve inner products? Yeah, as long as it's not metric, right? Like you can have well, okay, so to be clear, you can have a manifold that has a metric that, sorry, you can have a manifold whose connection doesn't preserve the metric, in which case the inner products aren't preserved. We have 14 South African rands from Russell Bale. Dark side of the moon? Well, I don't know what the question is, but there isn't a dark side of the moon. There is a far side of the moon. All parts of the moon get sunlight over the course of a month. Why do gravitational waves move the speed of light? Why is light speed the limit? It's more that there is a limit, and then everything that doesn't have mass moves at that limit. So gravitational waves don't have mass, light doesn't have mass, gluons don't have mass, so they all move at that limit. Is the arrow of time we perceive a result of entropy? Is entropy just statistics? Possibly, yeah. It's an open question, though. If space-time curves around mass, could I technically become a weapon by getting obese enough? No. What causes the compass to spin in the zone of silence in Mexico? I don't know. I have no idea what you're talking about. From Maddie Meister with the $5, why does stirring sugar in coffee make it dissolve faster, as in turbulence leading to mixing? So I suspect it has to do with and I'm speculating here, I don't know for certain, but if the liquid is static, you're only going to get diffusion happening, which is a fairly slow way of diffusing impurities or diffusing chemical differences out from some localized chemical substance like sugar. So if you have a sugar cube, and you don't stir it, then the coffee or the tea or whatever closest to the sugar cube will have the highest density of sugar, but the coffee away from the sugar cube will have the lowest density of sugar. So the idea is that if you stir it, you're constantly exposing the sugar, the sugar coffee boundary, to more coffee that has a lower concentration of sugar, which will more easily dissolve that sugar. So you're basically allowing it to uniformize more easily, which exposes the coffee to lower concentrations, which allows for better diffusion. That's my speculation. Do you have a PhD in math or physics? I'm confused. I have a PhD in physics. From Mr. Pecho, always good to see you. How big does something like the Death Star or Unicorn have to be before you start needing to worry about gravity? Is there a way to build a super huge thing without that concern? I imagine no, too much mass is too much mass. So what you could do is you could make it very large but very sparse. So you could make something arbitrary, like basically as large as you want, so long as it's not dense, there's not an issue. Like imagine just like a really, really thin scaffolding, right? I guess that would be a way that you could build it. Just kind of more of like a wireframe kind of thing, rather than like a solid chunk of metal. What do you think What do you think about meteorology? I think it's a useful field. Does the Earth grow bigger? It depends on what you mean, but generally no, not, at least not as far as I know, not noticeably. How did you come to love the lamp? So there's a story there. The story, it was during a debate. Somebody said that God is the source of randomness in the universe. And I said, according to Cloudflare, lava lamps are the source of randomness for our universe. It's a little bit of a paraphrase, but that's the idea. Cloudflare is a web hosting company or something. And for part of their encryption, they had like a wall of lava lamps, and they just took a picture and then sampled that picture to get kind of a random seed. And then I asked, "Are lava lamps God?" And he said yes. And so began the devotion, right? If Hawking radiation steals particles from vacuum pairs, is the black hole mugging space-time? Yes. Is sugar dense? I mean, density, whether it's dense or not dense, is a comparative thing, so you'd have to give me something to compare it to. Are you familiar with algebra topology analysis as much as differential geometry? No, not nearly as much. Again, my background is in physics. I learned differential geometry to do the physics I care about. And then it turns out I love differential geometry too. How do you get over the fear that your previous physics department will identify major flaws in your dissertation or retroactively fail your defense while everyone points out? Well, so funnily enough, that's not a thing that happens. But what did happen at the end of this past January is a colleague, or rather a co-author of a colleague, so someone I know on a casual basis, was looking through my dissertation and found a mistake. And it's not a small mistake. Well, okay, it is a small mistake, as in it's very easy to miss, because it was the part of the dissertation that it was found in was peer reviewed. It is published in a journal. It has 2 other co-authors. So like, this is something that none of my I didn't notice. My co-authors didn't notice. The peer reviewers didn't notice. My dissertation committee didn't. So it's a subtle mistake, but he did catch it. And so now we're in the process of basically issuing an errata. It doesn't change the kind of the core, the core flavor of the idea, but it does change the simplicity of the idea, which is a little annoying. What qualifications do I need to become a physicist? Work on physics as your occupation? Huh. How dense is sugar compared to a flat earther? Flat earthers are denser than black holes. What's your take on a recent realization that we have to adjust the standard model due to the LIGO data from earlier last month? I assume you mean the LIGO data. I haven't heard that we have to adjust the standard model. That's not something I'm familiar with. Are people who know physics just smarter than everyone else? Probably not. A subtle mistake that turned into a huge problem. Been there. It's not that it's a huge problem. It's an easy mistake to make. Basically, there's one thing that's left out in a proof, which makes the proof invalid. The proof is easily correctable. You just have to adjust the statement of the theorem, right? But what makes it a little bit tricky is, and the only reason it's been a kind of a pain to fix, is because we want to, when you're issuing an errata for a paper, what you want to do is you want to issue the minimum changes so that the core idea is maintained, but you don't have to write an entirely new thing. Now, the proof that had the mistake in it was about a kind of object that myself and my co-authors it's a new kind of invariant object that we described for the first time. And so the issue is that in the first paper, which is where this proof is, we didn't give the most efficient description. We gave a kind of, it's a correct description, or at least it's a fine description. It's just not the most general, and it's not the most easily handleable. It has a lot of underlying machinery that we didn't need to include. So the annoying thing is figuring out a way to issue an errata that doesn't require an entire new definition of the things that we're talking about, so that it fits into the old paper. That's the idea. And that's a little bit of an annoying challenge to solve, but I mean, in principle, if we could go back, we already know a better way to define these things. I define these things in kind of the most general way possible in a paper that I published last year. And so if we could use that definition to fix the old paper, that would be fine, but then it's kind of retroactive and it doesn't really work. From Maddie Meister with the $2, what age did you know you wanted to be a physicist? I was like 8 or 9. How do physicists feel about biologists? I don't know. Physicists are not a monolith. Could faster than light communication exist? Not as far as we know. Do you need pure math classes for your degree, i.e. analysis, abstract algebra, topology? No. I didn't, so I did an undergraduate degree in mathematics, and I did a double major, one in mathematics, one in physics, so I took a lot of pure math, but I hated analysis. Topology wasn't part of the degree, but I did take a lot of algebra. What is the topological quantum field theory, and how does it differ from regular QFT? I wish I could answer that question. I took one class on topological quantum field theory, and that was the class that I understood the least of all of the classes I've ever taken. You knew what a physicist was at 9? Well, I saw like a picture, like a rendering of a black hole. This was like right around when Google Images came out. So my friend and I were like just Googling images, and we stumbled upon an image of a black hole. And we were both like, that's so cool. Let's do that. Whatever that is, let's do that. And so then we looked into it and we're like, we're going to be physicists, and we're going to, you know, like, yeah, I had heard of what a physicist was. I had like read a biography of Albert Einstein when I was like 7 or something, or 8. So like I was like mildly aware. Let me drink some water, and then I'll go back to answering questions. No, my friend I think works as a banker now. He abandoned his convictions, but I also haven't spoken with him since like 8th, 9th grade. We just drifted apart. There wasn't anything in particular that, you know, like he moved away, we went to different schools, you know, the usual thing. Did you date a lot before getting married? Not a lot, no. I had like one girlfriend when I was in high school, and then I met my now wife freshman year of college. So, from Am Blake with the $5, what is your favorite QFT book? I'm starting a PhD in LQCD and kind of stuck looking for a good QFT book that explains things pretty well. I don't know of a good book. There are complete books. Weinberg is a complete book. It's a very good reference. I don't know of a book that explains things well, though, and that's a problem because QFT is a very, very complicated subject. When I was taking QFT in grad school, the professors that I had just used their own personal notes. So I'm just looking through the textbooks that I have on my computer. Yeah, Weinberg's pretty classic. Oh, Z. Z is fairly good. It's definitely easier than Weinberg. Quantum field theory in a nutshell. Did you study orbifolds? Do they have any use in physics? They do have use in physics. I didn't study them, but I'm familiar with their usage. From Sunapeak with the 25 AED. AED is United Arab Emirate Dirhams. Need to remember that. What the hell did that guy just say? Can you translate to English? What guy? Which guy? Your previous guy who asked the question? I don't know what the question. I'm sorry. If I see your question, if you can clarify, I can answer. Is space warp technology actually possible? I suspect not. Super chat guy. So he was asking about QFT. QFT is quantum field theory. And there's something called LQCD, which is lattice. So L stands for lattice. QCD stands for quantum chromodynamics, which is a branch of quantum field theory, or it's a type of quantum field theory that describes the strong nuclear force. So this guy, I guess, is doing his PhD in lattice quantum chromodynamics. What the lattice indicates is that instead of doing everything kind of continuously like you would do in calculus, you kind of break the universe down into like pixels, and then you do the quantum field theory there, and that gives some good numerical results that agree well with experiments, and the calculations are easier in that world. Now, they're not easy, but they're easier in the kind of discrete setting. From Chase with the $2, David Tong has free QFT lecture notes. Great stuff. Yeah, so I had a professor use David Tong's notes for a string theory class. David Tong's notes are very, very good. I'm familiar with them. I'm not familiar with his QFT lecture notes in particular, but I wouldn't be surprised that he was great. He's a great elucidator of physics. From Exploding Tiger with the $5. Since water is synthesized in stars, is it okay to call water star juice? Water isn't synthesized in stars. Oxygen is synthesized in stars. Water is synthesized on planets, perhaps, and also on, like, in gas clouds. From Akira's the Cat with the €2. What pops in out of vacuum? Isn't it in one state? Nothing. Vacuums are by definition static. That is one of the defining features of a vacuum, that it is unchanging, so nothing pops in and out of a vacuum. What does happen is if you stick a detector in a vacuum, it will detect non-vacuum excitations. That's just because the detector's there. And from Son of Peak, thank you so much for the super chat again. Very much appreciated. Dude just spent $7 to say thanks. Some people appreciate it. I appreciate them. What happens when an unstoppable force hits an unmovable object? I don't know, ask Aristotle. If atoms emerge from subatomic particles, molecules from atoms, etc., do you think that there's a final ground of fundamental particles, or can we always continue forever? I suspect that there is a fundamental ground, but that's not guaranteed. Why do I calculate deviation with sigma over square root n and sometimes with the double of it? Honestly, I just use it as a rule of thumb as a good approximation. And that's good if you assume your distribution is genuinely Gaussian. That's a good approximation. If your distribution is not genuinely Gaussian, well, then it's not a good approximation. Do you think that we will live to see Earth become a Type 1 civilization on the Kardashev scale? 2, could we mine neutron stars for the iron content? Will we live to see Earth become a Type 1 civilization? Type 1 civilization would just be covering the Earth with solar panels, right? So, like, I guess, I hope, but no guarantee there. Could we mine neutron stars for the iron content? That would be really hard because, as far as I know, there's no substance that could, like, survive on the surface of a neutron star. Blitz denies the quantum foam. The quantum foam is just something that you get when you make measurements. It's not something that's actually there when you have a true quantum vacuum. How does light have weight in a closed environment when it doesn't have mass? It's not the light that has weight. It's the whole system has weight. The system is light plus container. Because in some sense, mass, which is related to weight, mass is just the energy of a thing when it's not moving. And so you can take the center of mass of a box. The center of mass of a box with a light bouncing around inside of it is going to be fixed, right? Like, if there's no external forces, the center of mass of the box will be fixed. And so you can just say from in the center of mass frame of that box, there is some energy, and that energy is proportional to the mass. From DJ Eichmann, it's a crazy name, but thank you for the $2. Why do you hate analysis? I don't know. It's just, I hate, like, the estimates and the approximations are just, they seem so hairy and ad hoc to me. Do Feynman diagrams represent real particles? The ones on the edges do. Or the legs of the Feynman diagram do, but the internal lines, no. Thoughts on panpsychism from Abai Bueno de Misquita. I'm not convinced of panpsychism. I'm not, but it's also not something that's particularly interesting to me. From the Rabid Squirrel Sage with the $2, all hail the emissary of the lava lamp. Indeed, clack clack. Does Archimedes' law on an object submerged in water still make sense? Yeah. How come balls don't float on the water if the main thing inside it... Analysis of what? No, there's a branch of mathematics called analysis. Is our known universe inside a black hole? I suspect not. How does our universe inhibit a lower energy state of the Higgs field? Well, it's not clear that it does. There's this question of whether or not the Higgs is in a so-called metastable state, which would be that the Higgs field could be in, like, a low energy state, but it's not the lowest possible energy state. But there's a barrier preventing it from getting to the lowest possible energy state. And whether or not that's the case has to do with, like, the, you know, what the true quantum corrections are that we don't fully understand. And, you know, it's also teetering on some particular measurements that we need better values for. But it's not really being inhibited. That's just the way the universe is. It's the way the Higgs field is, rather. If light speed is constant, why things heat up after light hits a surface and bounces off it? That should mean that light becomes slower and is not constant anymore. Look, so when light heats up, what you have is that some of the wave is absorbed by the light, is absorbed by the thing that the light hits, like the surface, but not all of it is absorbed. Some of it will reflect off. So it's not that it's slowing down, it's just that there's less light that's bouncing off. Is it true that we recently discovered a point in astronomical distances where gravity no longer varies as the square of the distance between two masses and instead varies linearly? No, not as far as I know. There is this idea called MOND, modified Newtonian dynamics, which proposes that indeed gravity doesn't vary with the inverse square of the distance, but this is pretty fringe. From Ricky Ross with the $2, what's your take on observation theory and quantum? So what you're talking about is the measurement problem, which is just how is it that making a measurement causes us to get one outcome if the quantum state is in a superposition of many outcomes? And, you know, my view is that this is basically resolved by the many worlds interpretation. It just take the statement that, in fact, all outcomes are equally realized. You just become entangled with one of them. Analysis is just hieroglyphics with logic. True. If there was a boundary of the universe and an object passes through it, would the universe shrink? If there was a boundary of the universe, you couldn't pass through it, right? It would be there'd be no space beyond it, so you wouldn't be able to go there because there's nowhere to be. What degree did you get exactly, or what education did you get? I have a bachelor's in mathematics, a bachelor's in physics, a master's in physics, and a PhD in physics. I'm in the middle of a doctorate in education. I enjoy your teaching style. Have you taken any educational learning, or are you just good at it? Well, so I didn't take any educational classes. I probably should have, but I didn't. But what I did do is I taught at a university. I taught undergraduates for a few years. This is starting in like 2019, the summer of 2019, which is right before COVID. I was given my first class like as the instructor of record, and so, you know, I got like 3 or 4 years of experience just teaching at a university. Let me make sure I haven't gotten any cash apps that I've missed. Okay, I have not. Good. Good. If the speed of light is constant, what is it constant relative to? Relative to everything, actually. It's in any inertial reference frame, the speed of light will always appear to be the same constant. Could there be multiple colors or versions of the Higgs particle? Hypothetically, if we found such a particle, what would the ramifications be? There would be pretty significant ramifications, because this would mean that we're no longer talking about the standard model of particle physics. There are versions of this, yes, where I forget what they're called. Are they called like doublet Higgs models? Okay, so I guess they're just called 2 Higgs models. You can have like models of particle physics that have more than one Higgs field. From Exploding Tiger with the $10. Okay, serious question. It seems that some have a problem with an infinite regress, but no problem with an infinite progress. What are your thoughts on this? This comes from, in my view, this comes from the fact that we remember the past but don't remember the future, which is, at least if we understand time to be an emergent thing from like an emergent thermodynamic phenomenon, this is just a consequence of the fact that the future is less orderly in some sense than the past. And the past is able to, so more orderly things are able to leave coherent records, whereas less orderly things are not, so we're able to remember the past but not the future. But this is a cognitive bias, not like a real genuine difference. And so if somebody is making this claim that it's possible to have an infinite future without having an infinite past, then they should probably be able to distinguish between what makes it possible for there to be an infinite future, but not possible for there to be an infinite past. Usually this relies on an A theory of time, though. But actually, if you take the A theory of time seriously, then the past isn't real anyway, so there are no real infinities if the past, if there was always a moment of time before every moment of time. So that's something that's probably worth thinking about more. viewer count getting low? I mean, not really. We usually sit at around 300 on TikTok, and then another few hundred across other platforms. Do you think humans will ever discover at least 50%, if not all, of our oceans, or is that just not possible? We've discovered the entire ocean. What we don't have is we don't have sub-meter precision or sub-meter mapping of all the oceans, because that's probably not a good use of time. Why did Einstein assume that space-time torsion is zero instead of non-zero when developing GR? I don't know historically why, but it is a clean way of doing it. Oh, there's a moth in my office. I hate that. Do you think we live in a simulation? No, I don't think that there's strong evidence that we live in a simulation. I don't think that there's any evidence, really. Did you win? Hey Blitz, did you win the Flarfer debate with Angel of Light? Because he's saying otherwise. Yeah, and you can go watch it yourself if you want to evaluate it yourself. Go look up Dr. Blitz, Angel of Light, modern day debates. Sorry, not modern day debates. Go look that up and you can watch it yourself. You can evaluate yourself who won. Is there a chance that Planet 9 is just a golf ball-sized black hole in our solar system? People have written papers about this. But whether or not that's actually true is a different question. Did you study orbifolds? I already answered this question. On YouTube? Yeah, it's on YouTube. Angel of Light smack talks me because I don't let him up on my stream anymore because it's just the same thing over and over again, and I've already spanked him once. He doesn't need it again. Do you believe the universe is finite or infinite? I've heard finitist arguments related to Gibbs free energy. I'm agnostic about it. Although I'd be interested in hearing the finitist arguments about using Gibbs free energy. He didn't. It's a convention. Torsion is a kind of catch-all way to redefine the metric. Well, the Levi-Civita connection, he used the Levi-Civita connection in his papers, and the Levi-Civita connection is torsion free. What do you think about the Grim Reaper paradox? Do you think it's a good argument for finite past? No, because it fails for the same reason, or it fails to a parity argument. Will there be something smaller than quarks? Maybe, but we haven't found them yet. How do neutrino oscillations prove that neutrinos have mass? So neutrino oscillations are only present. So basically what you can do is you can write down a theory that describes neutrinos that have mass, and you can write down a theory that describes neutrinos without mass. And the way that you get neutrino oscillations to happen is if the flavor eigenstates are different from the mass eigenstates. And if the masses are all zero, then the flavor eigenstates are the same as the mass eigenstates. Namely, there's only one mass eigenstate and it'd be zero. So you need the neutrinos to have different masses in order for those two eigenstates to not overlap each other. And it's when those two eigenstates don't it's when those eigenstates, those sets of eigenstates don't overlap that you can get neutrino oscillations. What was the debate called? You can just look it up. It was on Modern Day Debates. Look up Dr. Blitz, Angel of Light, Modern Day Debates. You can just look it up and you'll find it. Is gravity a force? Yeah, in the sense that it is A, able to transfer momentum, and B, it is able to, it is the result of a curvature like all other forces. What's the best equipment to see atoms? Scanning, tunneling, electron microscopes. How does staring at black holes we never see or too far to touch actually help us here at home? Why do the deep space physics? I think that learning about the way the world is, the world that we inhabit, is valuable. From Wayne Cottrell with the 5 pounds, do you have any cool experiments I can do at home with my 9-year-old? Something cool, not the usual kind of question, I know. Depends on what kind of experiment you're talking about. You can definitely do a lot of home electronics, and those are really neat, but that requires some equipment and some knowledge. Something that could be fun for a 9-year-old is get a spinning chair. Ideally something that that can spin really fast, and then get some like dumbbells, and hold them in your hand, spin, and then hold them in your hands close to you, and then fling them out, and just see how your rotational speed changes. It's a conservation of angular momentum thing. That could be fun for a 9-year-old. Do you suspect the cosmological constant isn't a constant? Yes, I do. Or if there is one, I suspect it's not positive. As a physicist, what engineering profession would intrigue you the most? Probably like electronics engineering. Is gravity stronger than entropy? Those two things are not the same kind of thing, so they can't really be compared in that way. Are you like young Sheldon? I'm 32. How could I be like young Sheldon? Also, do you think that, like, to be clear, it's not like a flattering question to ask? So maybe don't. Can humans feel neutrinos and rain through in windshield? No. No, you can't feel neutrinos. Huh. Was that the one with Mark Reed? Yes, I think it was. Cloud chamber is possible, but you need some equipment for that. School robbed me? Oh, I don't think it did. Why don't scientists ever say don't know, like dark matter, I don't know matter? Dark matter, scientists say I don't know all the time. Dark matter is just the name. It's the label we give to this kind of matter that we don't know what it is. Whoa, have they proven all forces are a result of curvature, as you just said? The whole basis of quantum field theory is curvature and associated gauge bundles. So insofar as quantum field theory is true, yes. It's not curvature of space-time, it's curvature of different kind of, you know, you could think of them as like different internal spaces, but it's curvature nonetheless. From Ricky Ross with the $10, how does someone actually accurately gauge the distance of very far things in space when the medium is growing faster than light, can travel, plus if it was traveling for that long, wouldn't it have gone past by now? So, first thing, the medium isn't growing faster than light. Space doesn't expand at a speed in meters per second. Space expands at a rate, you know, for a given volume of space, it might double in size every 10 billion years or something like that. Second, when we say that a thing is XYZ far away, there are a few different ways that we can infer that. But yes, we do take into account the fact that the space-time is expanding. And that's how we can get this idea that, oh, the live is unstable. Average stream bitrate too high? What? Okay. So that's how we can get things like distant galaxies can be 30 billion light years away, even though the light has only been traveling for 13 and a half billion years or something like this. So yes, we absolutely do take that into account. The way that we measure things is using something called the cosmic distance ladder, or sometimes we just infer distance from redshift using the standard model of cosmology. So we basically look at the color of the thing, and we use that to figure out how far away it is based off of how much the color is shifted because of how fast it's going away from us. Yeah, it's just Twitch is saying that it's unstable. Maybe the bitrate is too high. Maybe I should lower that. I'll do it for next time. Do you think the Grand Exchange was a good update for RuneScape? If so, what's the most amount of GPU ever owned or your most valuable item? Okay, this is a silly question, but I'll answer it. I think that the Grand Exchange, was it good? It modernized the game. I don't know if it needed it. I think that it had pluses and minuses. I still have my original account from 2002. That original account has a Green Party hat on it. So make of that what you will. I don't know how much it's worth now. From the one corrupted with the $10, thank you so much. Can we solve the chaos of the multi-pendulum now? I think that there was a paper about three or four jointed pendulum, and they couldn't predict with full accuracy the path each joint would take. So the whole thing about chaos is that a chaotic system is one in which the position after some finite amount of time is non-linearly dependent on the initial conditions. So if you change the initial conditions just a teensy tiny bit, the final state can change dramatically. If you wait 10 minutes, the final state can be dramatically different after 10 minutes if you wiggle the initial conditions just the teensiest, tiniest bit. So this is a problem for computers. This isn't like a math problem that we need to like figure out how to solve. It's more that like computers have finite precision, and whenever we make measurements of things, we have finite precision. So It means that we can't get infinite precision, so we will never be able to predict the far future of chaotic systems given some initial conditions, because those initial conditions always have a little bit of error in them. But we can use heuristics. So is the curvature that causes virtual particles like the event horizon? Virtual particles aren't real. Virtual particles are field configurations. Bro just has a bachelor's. I have 2 bachelors, a master's, and a PhD. What is the likelihood of any of the island's stability being useful for humans? Look, so I'm not a nuclear physicist, but my guess is that the island of stability will probably not be that stable. That's my guess. Do you have a girlfriend? I'm married. What causes beta decay? Beta decay is what happens when you have a neutron that decomposes into a proton, an electron, and an electron antineutrino. Now, why that happens? It's essentially a quantum tunneling event. Actually, no, in that case, it's not a quantum tunneling event. In that case, it's just an instability of, I mean, the quantum fields that are at play in a nucleus are very complicated, but it's essentially an instability of a neutron, and it basically breaks apart as a result. I mean, like the gluons that are, sorry, the quarks are held together by gluons, but if those gluons, you know, they're in a quantum state, and so those quantum states can fluctuate. And sometimes they fluctuate in just the right way that they can, sorry, not the gluons, the quarks can fluctuate in just the right way that they can essentially, one of them can emit a W boson. And in doing so, it changes flavor. And it can give that W boson, well, yeah, so what's the correct description here? So there's kind of a top level description where you talk about neutrons decaying, and then there's a bottom level description where you're talking about one of the up quarks turning into a down quark. And so when one of the up quarks turns into a down quark, sorry, one of the down quarks turns into an up quark, the neutron becomes a proton, and in doing so, it emits a W boson, and that W boson carries with it some charge, and that W boson is unstable, so then it decays into an electron antineutrino. The W boson is, of course, a virtual particle, so it's really just a field excitation, but making me remember my nuclear physics going back 10 years. Do you think space travel will ever actually be feasible where traveling to somewhere won't be a 15-year process to get one mission done? I don't know, maybe, but we need to move on beyond chemical rockets if we're going to do that. Explain what you mean by virtual particles aren't real, just math. Yep, they're just real. Or sorry, they're just math. They're mathematical abstractions that we use to simplify diagrams. Is the physics inside the nucleus the same as that outside the nucleus? Well, I mean, the physics is the same, but the conditions are different. Doesn't the electron annihilate and become gamma rays? Not in beta decay. Is strange matter made up from strange quarks, and how does it turn normal matter into strange matter? So we don't know if it'll turn normal matter into strange matter, but strange matter would be made up of a strange quark, an up quark, and a down quark, if I remember correctly. And the idea is that that might actually be more stable if you have a large amount of it, but this is something that we don't know for certain. From Mr. Pecho with the $20, very appreciated. What's your favorite part of differential geometry from, say, your first year or two learning it, something not too deep into it? To keep me going on the cold nights as I learn how to differentiate the 200th widget I encounter. Yeah, so I learned differential geometry in the context of general relativity. That was my first exposure to it. So what I thought was super neat is that you can use the Einstein field equations and some symmetry conditions to derive the metric of a black hole. And from there, you can derive gravitational time dilation. That's probably, like, that's super straightforward in differential geometry. If what, like, you know, that's probably something that you would learn to do in your second, probably your second semester in differential geometry. As long as you know what the Ricci tensor is, You can define the Ricci tensor in terms of a metric, a Riemannian metric, of course, or a Lorentzian metric. Then you can just make some assumptions about that Lorentzian metric, namely that perhaps it's spherically symmetric, perhaps it's static, so it doesn't change in time. And then you can just write down what the, you can write down basically a set of differential equations, like ordinary differential equations, that once you solve them, you get the Schrödinger or the Schwarzschild metric, which is kind of baffling. And then you get gravitational time dilation out of that from writing the metric in terms of, you know, asymptotically flat coordinates and so on. So it's really, really nice to be able to see that just work. Did you make your personal site with AI? Yes, I used Claude. Is time a paradox in physics? I wouldn't say it's a paradox. Is computational capacity one of the major delays for physical advancement, or is the lack of other tech? It's not really a tech issue. It's a creativity issue in my view. I'm trying to get into geometric models for mathematical physics. What European university would you recommend for a master's to get the best experience? If you want to do the kind of like relativity kind of geometric modeling, probably the university or it's the large university in Warsaw is very, very good. They have an extraordinary GR group there, and they're very, very talented mathematicians there too. I'm sure I mean, of course, like Oxford and Cambridge would be excellent, obviously, but Warsaw is quite good. What university would you recommend for an astrophysicist? It depends on what kind of astrophysics you want to do, but if you're going for a bachelor's, you should just go to the best university you can, like the highest ranked one that you can. Why is it so easy to spot AI content? There's no obvious tell on your site, but I can just tell. I don't know. I mean, I'm not sure. So like all the written stuff, that's like obviously came from me. It designed the design, I guess. Have you read Sean Carroll's thesis? I have not. Would you say physics and philosophy have some similar areas of coincision? Philosophy leans on physics quite a lot. In your opinion, is gravity a force or an emergent? I think it's probably, well, yeah, I think it's probably a force. What are you currently working on? I have a lot of projects I'm working on, but one project that I've spent the last few days working on is, it's a project involving conformal submanifold embeddings. So if you go look at my thesis, or if you go look at the papers that I published earlier in my career, I worked on conformal hypersurface embedding. So submanifold embedding is a generalization of that. What's the difference between a physicist and a physician? A physician is like a medical doctor. A physicist is somebody who studies physics or who does physics. What's better, ChatGPT or Claude, and why? I don't like Claude just because the user interface is not great for me. At least it wasn't great when I was trying to use my website or design my website. So I use ChatGPT when I need to use AI, just because I already had a subscription to it because I was using it for some like other stuff. And so when I do use it, I use ChatGPT because I have the paid version anyway. And I don't like Claude. Are you a teacher in university? No. Claude Code is amazing. I believe that. I just don't code very often. What do you do as a physicist and how do you work? Well, so what I do is I do physics. I also do mathematics because mathematical physicist, right? What that means is that I work on research problems. Now, how I work, this is part of it. This is one of the ways that I fund my work, but often, if you're asking like what a workday looks like, often it's meetings, or I'm sitting and reading something that I need to know in order to work on some project, or I'm working out a calculation, or I am sitting there staring at a wall trying to figure out the correct way through a proof, or I'm writing a paper, whatever it might be. Is it true, and what do they mean, light don't experience time if EM equations are time evolving? So light, when people say light doesn't experience time, they're just wrong. They're wrong on like several levels. The first is that there is a sense in which light has a past, present, and future, so to say that it doesn't experience time is false. But even being even more technically correct, light doesn't have a valid inertial reference frame, so there's not even a thing to say about the proper time experienced by light. It's just not a well-defined notion. A physicist programmed by Globe Religion, ha 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 ha. So I just gotta show you guys this. He can't spell physicist. Like, that was the most embarrassing butchering of physicist I've ever seen. And it's even more embarrassing because it's literally behind them. It's literally right there. Where can we read your published papers? Go to my website, go to the research tab, and then you can find the titles, and those titles can be, you can just Google them, or I think some of them have a link on them. What's your vibe physics in the sense of using AI to assist your, what's your vibe physics in the sense of using AI to assist your work? I don't know what that question means. What do you mean, what's my vibe? So what is true is that I use like ChatGPT, the paid version, of course, not the base version, as like a sounding board and as a reference finder. So I think that it has value in that regard. You can kind of, the way that I've heard it described by another colleague is, it is like a grad student who knows everything, but doesn't know how to do anything. So again, if you use a paid version, AI is very, very good for telling you things that are known in the world. It's very, very good at summarizing things. It's very, very good at telling you whether something is true or false according to XYZ paper. It knows everything. It's not very creative. It's not very good at doing mathematics either. And it's not good at being original. But it knows everything. And so you can use it as like, almost like an oracle and be like, okay, tell me, has this been worked on? Has this particular thing been worked on in the past 30 years in published physics journals? And it will give you the right answer. Yeah, you can think of it like a really, really good Google search. Knows wrong things too. The paid versions hallucinate significantly less. When is it justified to use? Look, it's a tool. It's a tool like any other. You should use it when it's appropriate. You shouldn't use it when it's not appropriate. Like, you should never use it to write for you unless it's like an email that you can't be bothered to write. You shouldn't use it to do genuine thinking for you either. AI also lies and makes stuff up. That is true in the free versions. It tends to do it a lot more than in the paid versions, especially if you use extended thinking mode, and especially if you always ask in your prompts for any conclusions it comes to be grounded in, peer-reviewed literature or something like that. Which photo of the Earth would you use to prove flurfers as authentic? Well, so what I typically use is the 1972 blue marble, because that was before like AI was a thing. That was before Photoshop was a thing. This was a time when CGI was like super blocky. What grad math courses have you taken? I took abstract algebra, took functional analysis. I took, are those the only ones that I took? That may have been all I've taken. Yeah, I think so. Don't think Blitz is taking guests today. I will in 10 minutes. Are there machine learning applications in physics? Probably. Yeah, probably, for especially doing data analysis, but that's not the kind of stuff I do. From the one corrupted with the $2, ChatGPT is like a literate child, no wisdom. That's a way to put it. A very well-read child, perhaps. With entropy of the universe increasing, isn't it counterintuitive that density of matter gradates? That's one of the issues. It's not clear how to even define the entropy of the universe when the universe has gravity in it, right? Because gravity, if you let gravity do its thing, thermal equilibrium would be very clumpy. which is kind of counter the typical wisdom about what entropy does. So it's not clear how to even define entropy in a gravitating universe. Do you think you will ever become really influential in physics? I don't know. In some sense, I already am, right? When I go to a conference, I am probably the most well-known person there. Not by perhaps the people at the conference, but by the community, by the population at large. Now, if you're asking, will I ever become like a really influential physicist in the sense of like the physics that I do? Maybe. Who knows? The physics that I do is kind of niche. So unless it becomes particularly, like, what could happen is that the physics that I do is niche, but then we make some discovery and then it becomes super, super relevant. That could happen, but maybe not. What's your best advice for writing a first research paper? Send it to your professors and get them to give it a once over. As a physicist, do you believe in free will, knowing our brain is made of matter? I don't. What's my niche? I do conformal geometry. And I also do some like early universe cosmology, but that's like I do kind of fringy stuff. What contributions have you made through physics? Well, I'm published in physics journals, so those are contributions. Do you think 0-point energy will ever have practical real world Do you think 0-point energy will ever have practical real world application? I suspect not. Didn't you falsely accuse Caleb of being a Nazi? You realize that's defamation? Posting on Twitter that Hitler wasn't so wrong, I don't think that it's defamation, no. And I can go find the stuff for you. If you want. In fact, I think that I'll actually read, I know that some people have this stuff saved. I don't have it saved, but I know that some of my friends and mutuals and stuff have like saved images. He's taken it down, of course, but like this stuff was posted on his Twitter. So it's not defamation if the photo evidence exists, right? So maybe I should just save it. So if any of you guys who are watching, if any of my buddies are watching who have this stuff saved, just DM me on Discord and I'll put it into my research notes so that I can always access it later. What made you choose the field of research that you do? Well, I've always been interested in gravity, quantum gravity too. And the way I ended up doing exactly what I'm doing in kind of like the GR space is I just did what my PhD supervisor was doing because I really liked him personally. Like I really got along with him. He has a great personality. So I wanted to work with him. So I just did whatever he did. And it turns out that had a pretty strong overlap with the stuff that I'm interested in. What are your thoughts on conformal cyclic cosmology? It's beautiful. It's lovely. I think it's wrong. Why is freefall considered an inertial frame when you're undergoing constant acceleration? Because you don't have constant proper acceleration. You only have acceleration relative to a non-inertial reference frame. So when you were in geodesic freefall, you have zero proper acceleration. That's why you don't feel like you're moving. Caleb is his name on TikTok too. It's caleb.fe is the Nazi guy. My professor has offered to publish a paper on category theory with me for a final bachelor's project. Is this worthwhile over a theoretical physics project? My dream field is theoretical physics. If you have an opportunity to publish a paper, it's probably worth it. Unless you have an opportunity to do a theoretical physics paper, then that might be a better option. Is your research potential Nobel if you get cool breakthrough? I don't know. Who knows? Is that anti-gravity researcher who passed full of it? Yeah, we don't have any evidence that they were working on anti-gravity research. In differential geometry, what are the kinds of shapes they work with, or are they just generalizable? You don't really work with shapes. I mean, some people do, but I don't. You work with curvatures and manifolds and paths. My 2 doctoral supervisors don't appear to get on. Any advice? Pick one that you like and slowly start to work closer with them. Why can't light get any faster if its time is manipulated by gravity? So the speed of light is a speed limit for things that are near you. For things that are far away, there's no limit. Oh, don't forget to hydrate. Okay, thank you. My wife's lab made the cover of Nature once. Not pertinent, I just wanted to brag. Well, that's cool. It'd be theoretical physics project, no publication, versus pure math paper with publication. What would be more useful for a future in theoretical physics? The reality is probably that the math paper that has a publication would be more impressive for grad school applications. What would be more useful is the physics project. What would be more likely to get you into grad school is the math project, probably. What's your opinion on experimental or applied physics? Did you like the lab? Not really. Although I think I've probably become nostalgic towards it. So when I was an undergrad, I definitely spent a lot of time doing like designing circuits, designing lasers in my dorm room. So I had access to the physics department's machine shop, and so I would go down there and I would, make stuff. And, like I would make like heat sinks. And so like, I really liked working with my hands, and I would print out my own circuit board, design my own circuit boards, print them out, and then, assemble them myself. So I really like that stuff. But the actual like lab, like the actual data collection part is just kind of not insufferable for me, but I just don't love it. The design part I really like. I asked you previously if a black hole could be compared to anti-time or lack of time. You said no. Once you pass the event horizon, isn't all matter compressed, and would that not include time? So time isn't matter, so no, it wouldn't necessarily include time. And also, matter isn't compressed the moment you pass the event horizon. You can stay normal. If you fall into a particularly large black hole, passing the event horizon, you might not even notice that you passed the event horizon if you're not looking around. From Exploding Tiger with the $5, is there any parallel to the harmonic overtone series of sound in other areas of physics? Kind of. Yeah, so I mean, harmonic overtones are basically just, in some sense, you can think of them as standing waves, or at least they can kind of form standing waves. And standing waves are definitely very important. Standing waves are just waves that are able to fit in a particular set of boundary conditions. So those show up all the time, all over the place. Did you get to go to a lot of conferences in undergrad? I didn't go to any in undergrad. Do physics papers get to be really abstract upon concepts, or is it until a certain point numerical? Yeah, they can be really abstract. All right, y'all. So it is 10:30. I'm going to switch over to subscriber mode. So everybody will be able to watch, but the only people who will be able to send messages will be you know, like $4 or $5 a month subscribers. So give me just a moment and we'll switch that over. On live, I'm going to have to restart the live. I will be back in two jots of a tittle, as they say. But you'll be able to watch on any platform. We'll be back. And then I just got to transfer it over on YouTube as well. One moment. And by the way, this is just to encourage you guys to become members, because that is a good way to support me if you want to. And we'll also be bringing up guests to ask questions. This is another opportunity that guests will have to ask questions in voice. And then I just have to do this on Twitch as well. Thank you, Besso. Much appreciated. So we've transferred over. So welcome, welcome. Grandma used to say 2 shakes of a lamb's tail. Yep, there you go. Do you have an internal monologue? Sometimes. All right, let's bring up Edgar for some questions. Edgar, how's it going?
Yes. Greetings from Germany.
Hello from Germany.
My English is not the best, but I'm sure that we can understand us.
Your English is fine.
So I have a question with a centrifuge. Can I show a picture, a schematic picture?
Sure, but what's not going to happen is I probably won't be able to solve your problem for you if you have a problem. Like if you're having like a design issue, I probably won't be able to solve it for you.
No, it's not a problem. It's just a question because I have problems to understand some problem with that. Can you maybe make it big?
Not across different platforms, I can't.
Okay.
Because we're on several different platforms.
Maybe the small picture is enough. So imagine we have a closed room, 10 meters to 10 meters, and in the middle we put a centrifuge. Centrifuge, yes. Sure. And on the arm length is 4 meters, and on the end of this arm we put a gas bottle with 5-liter volume, and we cut the bottom of the bottle up so that it's an open bottle, and the open side is looking to the middle of the centrifuge. Mm-hmm. So by 4 meters length, if we turn it 11 rounds per minute, and if we make vacuum in this room, and now we put by 11 rounds per minute 5-liter atmospheric gas into the open bottle, we have a vector from 1g. Stays the gas in the bottle because we have a vector from 1g to outside, or is the gas flushing in the room of vacuum?
You're asking me to do a calculation live. I mean, you'd have to compute it. Now, what would happen is that so the 1g isn't necessarily 1g isn't enough to like contain an atmosphere, right? What you need is 1g over an extended distance. Notice that the atmosphere is not 10 centimeters thick, right? Even though there's 1g, it is hundreds of kilometers thick. So if you make the acceleration larger, then you will get a larger density gradient. It's more dense at the far end and less dense at the near end, but you'll always have a density gradient.
So by 11 rounds per minute, we reach 1g.
Right, and 1g is not enough to contain a gas over 10 centimeters.
100g. What happens
as the acceleration gets higher? As the acceleration gets higher, you will get a steeper gravitational gradient, and so you'll have more of the gas contained within the container.
And you believe that the gas stays in the open bottle by a room with vacuum?
Well, you will have a density gradient. You'll have a density gradient. The higher the acceleration, the larger the density gradient.
And then it's possible that we can hold the air compressed in the open bottle against the whole room of vacuum.
If you have sufficiently large acceleration, yeah.
But we make this test, and we observe that
what was the acceleration that you used?
No, so much more. So
what did you use?
If we rise the G to 10G or 20G, it's not possible to hold the atmospheric gas.
Okay, so did you calculate what the expected gravitational gradient is from the gas?
Yeah, but the
and did you compare it with you're not answering me. Did you compare the expectations with the experimental outcomes?
The expectation was not true. Because
it sounds like you didn't actually know what the expectation is.
No, we try and see what happens.
What was the expectation?
The expectation.
What was the theoretical prediction, and did you compare the theoretical prediction with the actual experimental outcome?
Gravity has the possibility. The expectation of physics says that the air staying inside.
Yeah, over hundreds of kilometers. You need a bottle that's hundreds of kilometers long.
And why it's not makeable on a labor behavior?
Because the gravitational force on Earth is what's causing the density gradient in our atmosphere, right? Please hear me out. This is not a debate. I'm answering your question, okay? This is not a debate.
1G taking
this is not a okay. I'm sorry, Edgar. This is not a debate. I'll explain. So, the Earth's gravity produces a certain gravitational or a certain density gradient of the atmosphere, right? So you'll have a higher density near the surface and lower density as you get higher up. But importantly, the density of air here at sea level is going to be basically the same as the density at 10 meters up, which is basically the same density as 20 meters up. So we only see that density gradient actually happening over kilometers, right? And so if you wanted to reproduce this kind of density gradient in a vacuum kind of thing, you would need to shrink that density gradient dramatically, probably by hundreds or thousands, by a factor of thousands is my guess. You would have to work out what the actual relation is here. But for a given height, you need to find the relationship between the density and the gravitational pull. And so the fact that our atmosphere extends over hundreds of kilometers, if you want to shrink that down to over the order of a meter, my guess is that you would need to change the you would need to change the acceleration by like a factor of, I don't know, 100,000. So you'd probably have to do like thousands of Gs, not 10 or 20 Gs. Anyway, I'll answer some more questions. From Josh P with the $2. Is space actually a liquid like some scientists say? I've never heard a scientist say this. I don't know if space is a liquid. I don't think it is. Also, Chase just become a member. I guess you weren't a member before, but welcome to being a member. Appreciate you. It's only $4 or $5 a month, and you get access to these live streams. We could exist our universe within a black hole based on the event horizon description. Kind of, sort of, but not really. The issue is that in order for it to be a black hole, you'd have to have basically nothing on the outside and lots of stuff on the inside. But as far as we can tell, the universe is basically homogeneous, meaning that there's no area of high density and area of low density, and we're in the area of high density, and we'd be surrounded by an area of low density. That's the only way that you would get a gravitational. That's the only way that you would get an event horizon to form. So any mass radiates Hawking particles. That is debated. Would something with negative mass have a negative weight? Would a scale read 0 if you put two things with the same mass and negative weight? Or with the same mass and negative mass? We have no idea how negative mass would behave. But yeah, if it's negative gravitational mass, then yes, that is what that would mean, which would be weird. From L'Oreal Ashley with the $25. Thank you so much. Also, yeah, if you become a member, and we are working on getting TikTok superfans also access to the debate notes, but if you could become a member on YouTube, we're also working on getting this done on Twitch too. If you become a member on YouTube, you get access to my debate notes, which have a lot of useful sources of information and things like that. And again, I'm hoping that the TikTok superfans and Twitch subscribers will get access to that soon. But we're working on it. Any mass disturbs quantum modes? Yeah, it should. Can you explain the experimental verification of a manifold? Like, do they physically exist or are they just mathematical tools? That's a question of philosophy more than it is of physics. The point is that if the universe is well described by a four-dimensional Lorentzian manifold that we call spacetime, then the expectations of the way the universe is, things like frame dragging, all of these sort of kind of manifoldy, different general relativity effects, these would be real, and we do in fact see those things happening. Like we've experimentally detected frame dragging, for example. Can you explain how a beam of light still moves away from you at c, even if you're traveling at 99% of c? Velocities just don't add that way. The point is that, and kind of time dilation and length contraction come to the rescue. From your perspective, if you're traveling at 99% the speed of light, everything looks like it's much, much shorter. So the light is able to travel, it's able to cross by more things in, so yeah, how do I want to phrase this? From your perspective, light is traveling at the speed of, from your perspective, you're stationary and everything's moving by you quite quickly and light is just moving at whatever speed. Right? Okay. From somebody else's perspective, they will see you going quickly and they will see you just barely lagging behind the speed of light. But they will also see that your clock ticks way slower. So they will infer that you will measure the same speed of light because your clock is ticking so slowly. So it's able to cover more distance in one tick of your clock. Just checking for some more questions. Which millennium problem, if solved, will have the biggest impact on our understanding of the universe or just physics in general? I think the only one that... my guess is the Yang-Mills mass cap problem. But it's hard to say. Hard to say what actually would have an effect. All right, let's bring up another guest. Come on, pop up. I don't know why the multi-guest thing isn't working. Okay, let's bring up Kevin. Kevin, how's it going?
Hey, how's it going, man?
I'm doing all right. Kevin, what questions you got for me?
Yeah. This one is the easy one, but me and my partner have been dating for about 6 years now. She always, tells me about when I'm gonna marry her and stuff. And I just don't know. Like, do you know when I will propose to her?
Yes. Hold on, I'm contacting the spirits. It'll be on November 19th, 2027.
Wow, my days, wow. You're the best psychic ever, man.
I'm glad you think so.
Can I do one more?
No. Can you explain quantum entanglement over time? No, I'm not sure I fully understand it, and it's really... So I've looked into it a little bit, but I need to do some more reading on it because it's not something I fully understand, or it's not something I understand well enough to communicate at this point. What did Michio Kaku mean when he said everyone in his field doesn't use the scientific method? I have no idea. I think that Michio Kaku just says things sometimes even if they're not true. I think he just says things that feel right. Who knows? Who knows what the man is thinking? All right, we do have a guest on Discord that I'll bring up. Talk to Deadmile. Deadmile, how's it going? You gotta unmute yourself, by the way.
Well, that's a little embarrassing.
You're good.
Pleasure to be here.
Yeah, glad to have you. So, what questions you got for me?
Yeah, mine aren't particularly related to any specific scientific question, but I kind of wanted to ask you about your journey in physics and college.
Sure.
I'm personally right now going through my astrophysics bachelor, and I just wanted to know, how did you come to find like the fields that you specifically find super interesting in physics when it's such a wide array of stuff?
So, I don't know how unique my story is. When I was a kid, like 8 or 9, I was already like super interested in black holes. and like I read biographies by Albert Einstein, and I watched, you know, the PBS specials on like string theory. So these were already things I was interested in since I was like a young kid. And so basically I knew that that was what I was interested in. And then I just kind of took classes in a way that would hopefully prepare me for that. So for example, my senior year of undergrad, I took a class on general relativity, which was a grad class, but I asked the professor and he was fine with it, so I took it anyway. I took some other classes that were unrelated just because I found them interesting. I took a grad class on abstract algebra, a grad class on, one grad class on abstract algebra. I took some particle physics stuff, but I was already in the boat of having a particular interest, and so that was kind of where I was trying to get to begin with. If you don't know yet, you just know that you like physics, you have a very, very wide array of things to choose from, and a very, very large set of things that you can kind of go try out. What year are you in?
Well, I'm a freshman, but I'm a junior in credits, so I'm just getting into my astro-based courses. I'm
Okay.
sort of similar to you. I've just more generally, I've had an interest in large-scale space,
Sure.
less applied in the solar system, and so it's just very intimidating because there's a lot out there.
Yeah, so what you'll find is, and I don't know how true this is for everybody, but at least for me, in grad school, I ended up working with a person because I liked who they were as a person. Like our personalities meshed really well, and so I just did whatever they did, and that happened. Like I got lucky. That happened to like kind of align with my interests anyway.
Okay.
That said, when you go to grad school, again, I don't know how this was. I don't know how this is now. I was applying for grad school 10 years ago, so make of that what you will, or more than 10 years ago now. I guess the beginning of 2015. So, but when I was applying to grad school, you kind of didn't really, there was no expectation that you would know what professor you're working with if you go somewhere. I mean, like when you're writing your letter about your, statement of purpose or whatever, you might say, oh, well, the research of XYZ professor is interesting, or the research of ABC professor is interesting. But there's no, that means nothing. It means nothing about whether or not you're going to work with them. It's just kind of like oh, it seems interesting, maybe I'll think about it. But what you'll find is that you'll have the opportunity to talk with a lot of professors in grad school, even if you don't know what area of astrophysics you want to work in. As long as you know if you want to do observational or theoretical or computational, if you know which of those you want to do, then you will.
Computational. I know that for a fact.
So then it's just a matter of talking to the computational astrophysicists wherever you end up at grad school, or you can talk to them while you're in undergrad and just have them tell you about the research. And if it's interesting to you, be like, hey, got anything for a upper division undergrad or a baby grad student? And if they have something for you and it seems interesting to you, then you can do it. Otherwise, you can pass and you can go talk to somebody else.
Okay. Thank you. That's really helpful. Am I allowed to ask multiple questions?
Yeah, go ahead. I try to keep it to 10, 15 minutes or less, but you have plenty of time, so you're good.
Okay, cool. Thank you. I was also curious if you're working on new papers right now. I've seen some of your videos on your papers, and I think this stuff is so cool. I was curious what you're working on now.
Yeah, so there's a lot of things that I'm working on. I have this bad habit of, well, maybe it's a good habit. I tend to work on a lot of things at the same time, or have a lot of ongoing projects. Now, by the way, this just as a word of advice, this is probably not the thing to do in grad school, because in grad school you really want to dive deep on one thing and then work on that. But once I finished grad school, I basically picked up 6 projects simultaneously, and so and the reason why that's nice is because it means that if you get stuck on one problem, you can just go work on some other problem, and then hopefully you'll just by existing, you'll come up with some way to get around your being stuck. But yeah, so to answer your question directly, there are a few projects I'm working on. The most physicsy project that I'm working on right now is a model that I'm working on developing for early universe cosmology. It's sort of like a big bounce model, but it's statistical in nature rather than deterministic.
Okay.
I don't want to go into a whole lot of other details because it's kind of in the infancy stage right now. And,
no worries. Yeah.
But that's something I'm working on. I also have a few projects that are I have fewer than 6 projects active right now. I have a few just kind of pure mathematical projects. One of them is sort of an extension of my PhD work. Another is kind of this this new business involving integrated conformal invariance, which is it's more pure mathematical than anything. Yeah, I guess those are the 3 projects that I have going on right now. Just looking through my list of things to, I have a few other things that are kind of like at the very, very beginning that I'm just talking to people about that aren't actively being worked on. But yeah, those are the things that I'm working on right now.
Very cool. I had just another question.
Sure.
How do you find people to reach out to do research with in these fields?
When you're a grad student, you just wander into their office, maybe shoot them an email beforehand and be like, hey, I want to hear about your research.
Okay, that makes sense. That makes sense.
But when you're not a grad student anymore, it's,
yeah, that's what I was
you'll run into people at conferences, which you should be going to when you're, once you finish grad school, if you want to stay in academia, which not everybody does, but if you want to stay in academia, you need to go to conferences. So even though I don't work at a university anymore, I'm going to a conference in July. It's not cheap, but I'm going to a conference in July just to stay in the loop. And so you can meet a lot of people there. Eventually, once you go to enough conferences, especially in the same field, you start seeing the same regular crowd, but occasionally that regular crowd, even if they're not collaborators, they'll be, friendly faces. And maybe one of them will give a talk, and then you can be like, hey, we should write a paper. I have this idea. So conferences are a good way to meet people, asking questions. People always want to talk about their research at conferences. And worst case scenario, you can just shoot emails. It's good if you have a .edu email address, though. That's definitely a helpful, handy thing.
Yeah, that makes sense.
Because, otherwise you're less likely to get a bite. But yeah, that's probably the other thing is sometimes people reach out to you. And, then you have something to work on together.
All right, thank you. And if you had any advice for undergraduate students trying to get into stuff like this and pursue like a doctorate, what would you give?
Sorry,
I don't mean to spring that on you.
No, it's fine. Get into as good a grad school as you can. And when I say as good, I don't mean like, where there's like one guy who's like, really, really good in this niche area. What I mean is, if you don't know exactly what you want to do yet, go for the highest ranked grad school you can. So if you can get into Yale, go to Yale. If you can get into Harvard, go to Harvard. If you can get into MIT, go to MIT. The thing about the reality of academic work is that prestige matters a lot. And so being able to keep a job is unfortunately very heavily dependent on prestige. So if you can, get into the best school you can. And if that means as an undergraduate, studying your ass off or writing as many papers as you can or studying really hard for the physics GRE, do what you can.
Oh, yeah. All right, cool. Perfect. Hey, thank you.
Of course.
It's been a pleasure. Seriously, this was some helpful stuff, man. I love your videos, love your papers.
So
I read your
sweet.
microgravity one. I didn't understand a lot of the math, but I think it's very interesting relating to like the cosmological constants.
Me too. That's why I wrote
I think that's super cool.
All right, but I'm gonna let you go, Dead Mile. Thanks for being here.
Yes.
Take
Thank you.
care. All right, let's answer some questions and we'll bring up our next guest. My professor said Michio Kaku is the Guy Fieri of physics. I don't know if that's correct, but I don't know, man. Brian Greene is really good at explaining these things. Maybe look at a video by him or read one of his books. Brian Greene is really, really good at explaining things. He's just a super shill for string theory. Chase Martin says, I highly recommend meeting the department in person. Yes, that's very helpful. Yep. If you can, when you're applying for grad schools, if they will fly you out so you can check out the department, that's very, very helpful. That's why I ended up, so I could have gone to UCLA. I got into UCLA for grad school and I got into UC Davis for grad school. UCLA is in some sense, it's a higher ranked school, right? It's a higher prestige school, but the department at UCLA just didn't, I don't know, something about it just didn't feel right. From Akira's the Cat, should the Ritchie scalar be treated different in Einstein's field equations? I don't think so. Why would it be treated different? How much does conference cost to attend? It's not often the cost to attend. Like some big international conferences will have a conference fee of a few $100s. It's just that you have to fly there and then you have to book a hotel, and that gets pricey for a week. Right? So I'm going to a conference at Penn State in the middle of July, and there's no registration fee. And it's organized by two colleagues of mine. But a flight to and from Pennsylvania is going to be $500. The hotel that's close to the conference location It's $170 a night, so that's staying there for 6 nights. So that's another $900 or so. So it just like it's not cheap. Sorry. All right, let's bring up Matthew Davids.
Yo.
Matthew, how's it going?
It's going good. How are you doing today,
I'm doing
sir?
all right. What question you got for me?
I love you. Yeah, I just wanted to ask you, do we have a physics model that goes infinitely into the past?
Sure.
What is it?
I mean, I wrote one. I wrote a paper that was
I
recently
thought it
accepted.
wasn't done.
Sorry?
I thought it wasn't finished yet, you said.
No. That's there's another thing that I'm working on, which is kind of separate. But I have a paper that I published last year that is cyclic and has no beginning.
Okay, what's the argument?
It's not an argument; it's a model.
What's the model?
Yeah, it's. I called it a breathing universe. You can look up the paper. It's called a breathing universe is consistent.
So is it like a mathematical possibility? Is there any empirically observed evidence or no?
Yeah, I mean, so it is a mathematical possibility. It relies on well understood physics. So the purpose of that model was to investigate the whether or not you could even build such a self-consistent model. And the answer is yes.
Okay, does it escape BGB theorem?
Yep.
Okay, how?
It doesn't have the doesn't follow the weak energy condition. It doesn't obey the weak energy condition.
It doesn't expand?
It does expand. By the way, the BGB theorem is not a
Is
theorem.
your model a closed system?
Is it a closed system? Do you mean that is energy conserved?
Is the universe a closed system?
Do you mean is energy conserved? Because no, energy is not conserved in my system.
Okay, where does energy come from?
Energy is not a substance.
Okay, so energy doesn't exist.
Well, it's a number. Yeah, it's not a substance. It's not conserved in an expanding universe. But look, Matthew, this isn't a debate space. This is a ask
No,
a
I'm not trying to
physicist
debate.
space.
All I've asked so far was just questions. How many questions can I ask?
I mean, you can ask as many as you want, but just try to keep them, charitable and
Yeah,
in
I'm not
good
trying
faith.
to debate.
Okay.
Yeah.
So you should go read the paper. It's interesting.
Yeah, I'll look up on it. But is there any
I can
like
pull it up
actual?
for it if you want.
Okay, yeah.
Yeah. It's actually, you can go look at the most recent version, or you can go look at the.
Can I find it like right now?
Yeah.
What do I search?
And just search a breathing universe is consistent.
A breathing.
Yeah. Here's the paper, by the way.
Universe is consistent. Let's see.
Here's the paper.
Oh, it's on the
short.
screen.
Yeah. It's short.
Introduction. Oh, I think I saw this before.
Okay.
On your YouTube.
Maybe.
Samuel?
Yep, that's my first name.
Oh. So you're saying like a breathing universe, a cyclical universe that expands and contracts, right, is consistent?
Mm-hmm.
Okay. So from my understanding of how a breathing universe, what a breathing universe means is it like refers to a cyclical or oscillating model, right?
Well, I don't know if breathing universe was used in the literature before this paper. But sure,
So it's
yeah,
one-
that is how I'm using it.
Okay, so one that expands from a big bang, right, and contracts in a big crunch.
There's no singularities involved in this model.
You don't believe in the singularity?
Well, there are no singularities in this model.
Oh, so it doesn't. Oh, so there's no beginning
Right.
of the expansion.
Well, there is a beginning of the expansion. It's just not a singularity.
Oh, okay. So you're saying, yeah, I understand. Well, yeah. Well, does the BGB theorem says that any universe that has been expanding on average cannot be eternal in the past?
This
right?
universe hasn't been expanding on average. It has an average expansion of 0.
Oh. Oh, okay. It doesn't expand, like.
No, it has an
What does that
average
mean?
expansion of 0, meaning that it expands for exactly as long as it contracts.
It expands for as long as it contracts?
Yes.
What does that mean?
Which part did you not understand? There's a certain amount of time for which it expands, and there's a certain amount of time for which it contracts, and those amounts of time are equal.
Oh, so it does expand.
It does expand, and then it contracts. Yeah.
Oh, yeah, that's what I'm saying.
Yeah.
Like, I thought you said it doesn't expand.
It does. I didn't say that. It definitely does expand, and then it definitely does contract.
Okay. What expands?
The scale factor. You can go read the
scale
paper. It's
factor.
pretty, in my view, it's pretty simply written.
Well, I didn't read it all. I just remembered off your page.
Well, you should go read it.
So you're
It's only
saying-
7 pages long.
So it does expand, though,
It's actually
right?
it's actually closer to like 5 and a bit pages long, right? So it's not very long. You can go read it.
Oh.
The
Yeah, I
last
have
pa-
another
the-
question.
Yeah, go ahead.
Yeah, my question would just be like, does the Big Bang say that the universe began?
No, I don't think it does.
Okay, why?
That's just not what the Big Bang model is about.
Another question, does the Copenhagen survey say that the Big Bang doesn't say that time began?
Does the Copenhagen survey say that the Copenhagen just is a survey of people, so it doesn't say anything about what's true? But it
Yeah.
says what the physicists' view of what the Big Bang is.
And that the Big Bang is not an absolute beginning, right?
Right, that's what the
Absolute meaning
Copenhagen
that they're not
right.
absolutely certain that it's the beginning.
No,
Not that it's not a
absolute-
beginning.
No, the claim is that it's not an absolute beginning, or rather that it doesn't say anything about whether there's a beginning or not. You can go look at it. It seems like you don't really want to ask questions in good faith, though.
No,
because
these are all questions. I'm just
Why would
trying
you
to
ask
understand
that
'cause-
question if you've looked at the Copenhagen survey already?
Because I know that the Copenhagen survey says itself that it says not an absolute beginning of time, not that time did not begin. So where does it in the Copenhagen survey say that time did not begin?
I never said that the Copenhagen survey says that time did not begin.
Well, the people that you give the survey to, like Deconstruction Zone, go around and argue that it actually says that.
Then
so-
argue with them. Why are you here arguing with me? If you
Well,
have
no,
physics
I'm just
questions, you
wondering.
can. You know what? Actually, you don't even need to be here. If you have physics questions, you can ask me physics questions. It sounds like you want to interrogate me, and this isn't the space. By the way, we can pull up the Copenhagen survey if you want. We can just go look at exactly what it says. It's actually like a fascinating survey. And so the statement of the Copenhagen survey, it's pretty straightforward. The one that got the majority of the views. It's just that the Big Bang, the meaning of the Big Bang is that it's a theory that says the universe evolved from a hot, dense state that says nothing about whether there was an absolute beginning of time or not. So the understanding amongst physicists, and this is the view that I hold, is that the Big Bang as a model just doesn't talk about whether there's a beginning or not. That's just not what the Big Bang's about. That's how it's understood by physicists. Anyway, let's bring up another guest. Let's talk to Will Day. Will Day, how's it going? Will Day? Will Day, you gotta unmute yourself. Will Day. All right, I'll bring up another guest from TikTok then. Let's bring up Hitch. Hitch, how's it going?
Hello. Hi, Dr. Blitz. Thanks for accepting.
Of course. Yeah, Hitch, what questions you got for me?
My question was going to be about the conservation of energy, although just a moment ago, you very quickly mentioned that energy is not necessarily conserved, but I didn't hear the end of it. But
Yeah.
anyway, my question is, if there was a conservation of energy, then how is that explained with the loss of energy of a photon traveling through a redshifted photon traveling through the expanding universe?
Well, so if there was a conservation of energy, photons wouldn't be redshifting,
Okay.
right?
Simple as that.
Photons redshifting is an example of energy not being conserved.
Okay, that's really interesting because I thought about this question myself and thought that conservation of energy was a fairly universal or fairly fundamental law, but it's not the case. Can you explain that a bit more to someone like me?
So prior to the early 1900s, we kind of just took energy conservation and momentum conservation. We kind of just took these as like, for lack of a better word, gospel. And so what that meant is that they just assumed it was universally true. And then Emmy Noether comes along in the 1910s, and she actually gives an explanation as to why certain quantities are conserved. So she provides a mathematical theorem, this first theorem, that establishes under what conditions there are conserved quantities. And what she establishes is that if, for example, you have a system, if you have a system that's described by a mathematical object called the Lagrangian, such that the mathematical object obeys a certain symmetry relation, namely, for example, if you take all of the positions and you shift all of the positions over in the formula by like 1 meter to the right or 1 meter up, and it doesn't change, if you are allowed to like kind of translate your whole system without changing the Lagrangian, then that implies there's momentum conservation. And that's mathematically provable. Similarly, if you can rotate your system without changing the Lagrangian, that again implies you have angular momentum conservation. And finally, if you can show that your Lagrangian is unchanged by shifting it forward or backward in time, that implies energy conservation. And so now we have a reason to know, or we have a way to know when systems will have certain conservation laws. And so if we look at the universe as a whole, you can describe that universe, our universe, in terms of a Lagrangian system. In fact, you can do this even just for a basic general relativistic universe that is expanding. And what you'll find is that Lagrangian is different at different moments of time if the universe is expanding, for example. And so because the universe doesn't have this, it's called a time translation symmetry. If you shift it forward in time, it's different than if you don't shift it forward in time, then you just don't expect any amount of energy conservation. And the reason they didn't know this in the 1800s is because A, they didn't have this formulation of what a conservation law was, and B, they didn't know the universe was expanding.
Okay, that's really interesting. So, where does that leave us philosophically? If energy can change, there's no conservation over time. The Lagrangian shifts, then does it change arbitrarily? Can any amount of energy be lost or gained, or is there any?
It's just that there's not a well-defined notion of energy.
Okay.
So
you're trying. Okay, so trying to say there's a conservation of energy is like trying to apply a concept which just doesn't make sense.
Yeah. So energy is defined as that quantity which is conserved in time translation invariant systems. But our universe isn't a time translation invariant system. That's the name of the symmetry. And so there just isn't a definition of energy that is, in some sense, like universal for our universe. There's just, now you can try your best to define energy. So like we have a way of defining energy in like everyday life, because at the scales of everyday life, the universe isn't expanding. We can treat energy as if it's conserved, because for all intents and purposes it is, because we're not the size of, galaxy clusters or whatever. And so if you try to take that notion of energy and you kind of try to glue it on to an expanding universe, you can do that, but then you find that it changes in a very, very specific and predictable way. For example, photons redshift. So if you try to apply the notion of energy to a photon as we normally would on Earth, it's just the frequency times Planck's constant, what we find is that in an expanding universe, the frequency changes in a very predictable way, and so the energy of the photon goes down. So if you take the normal definition of energy, like the standard ones, then it's not arbitrary. It's a very specific way in which it changes, and we can write down laws for how it changes and things like that. But there's not really a universal way to actually define energy in a clean way in an expanding universe.
Okay, that's really interesting. I've got maybe two more questions.
Sure.
Before that, follow up on that. I find really interesting what you said. I'm surprised that I didn't know that already at this point. But have you got any sort of literature or sort of not some sort of accessible literature which you could read on this type of topic? Background, I did study physics at university 14 years ago, but my knowledge is definitely waned since then. Have you got any just recommendations for literature in general for someone who hasn't kept up with physics, is kind of accessible, and will explain some cool topics?
So I think this might be covered in Sean Carroll's book, The Biggest Ideas in the World, Volume 1. Or Biggest Ideas in the Universe, I'm sorry. I think it's explained in that book, but it's been a while since I've read it, and I read it on my phone, and I don't have the app anymore. So I don't have a hard copy, so I can't check. But I think it would be covered in that book, and if he didn't, it would be very irresponsible not to. So, and even if it's not, it's a good book anyway. So that might be the place to go find it. It's pretty accessible. It's not a textbook. but it does go into some pretty deep ideas.
Okay. Okay. My last question then is: I remember when I was studying physics, one of the things which I found really beautiful was the way that the speed of light drops out of the Maxwell equations. And I was just wondering if you could inspire me with something in physics which you think is beautiful, maybe I haven't thought about before, and something which you think is worth the effort to understand. And
You're asking me to inspire you on demand. All right, give me a sec.
yeah. Is there anything that you think about which keeps you going in your career, and you think, yeah, this is really...
Well, there's a lot of stuff that I care about that's really neat. Like, I care about figuring out what's going on, like the different ways that we can try to understand what the deal is with the Big Bang. But it's a fairly, like, the kind of stuff that interests me is like fairly technical. It's like very model buildy. It's kind of like building, you know, I don't know, like building Legos rather than like some particular idea. But something that's probably worth thinking about, something that I think is really, really interesting to say the least, is just the content of what general relativity is about. So what general relativity is about is that there's kind of two pieces, in the same way that electromagnetism kind of has two pieces. So electromagnetism, there's the piece that tells you it's Maxwell's equations that tell you what shape the field takes. And, you know, so if you know what the charge is, if you know what the current density is, then you can figure out what shape the field takes. And then from once you know what the fields are, then you can use the Lorentz force law to figure out what path objects traveling through that field move along. So general relativity is very similar. You have the kind of the field equations, which are Einstein's field equations. These tell you what shape space-time takes when you put matter there. And then you have the geodesic equation, which tells you what trajectory objects travel through that space-time. Now, of course, these are related, but that complicates it a little bit. But the interesting thing is that, for example, with very, very few simple assumptions, namely spherical symmetry and unchanging in time, you can derive the space-time structure of a black hole. This was done in 1916 or something. A few months after Einstein came out with this paper, Carl Schwarzschild did this, and it's super, super straightforward to do. It requires a little bit of differential equations, but like it's you know, proving that a black hole can exist just from some symmetry assumptions is very, very interesting to me. I think that's surprising. So I don't know if that does it for you, but it definitely did it for me.
Oh, that's interesting. Have you got time for another question?
I suppose.
Okay, last one. I think the reason I studied physics is when I was younger, I kept asking why and felt like I needed to study physics to answer some of my questions. But I miss physics. I do a more mundane career now. But what was left with me, I felt like I went as far as I could with physics and then was left with more questions which were more philosophical, and especially because your interest seems to be more in cosmology, Big Bang. How much do you cross over between physics to philosophy? Do you stick in your own personal interest well within the bounds of physics, or you know, are you more interested in the philosophical side as well, and maybe questions which are outside the scope of traditional science? So
I'm definitely interested in philosophy, but only insofar as philosophy, like the parts of philosophy that I'm interested in. I'm I'm cursorily interested in some philosophy, like philosophy of mind and things like this. But like the actual philosophy that I think about a lot is just philosophy based on what physics can tell us. It's like, you know, not philosophy of physics, but the philosophy derived from physics. So questions about like, what is time? That's a philosophy question. It's also a physics question, right? And so those are the kinds of things that I'm very curious about.
Yeah, I think me too. Time in particular, and the concept that is there any way of proving that time actually flows? And that's something I think about a lot. And
sure,
I don't know whether that's only a philosophy question, not a physics question, because
yeah, I mean it might be a physics question, but it's not a question that we can answer yet.
Yeah. Okay. Well, thank you very much.
Of course. Thanks for being here. All right. We have some more questions, I think. Well, I don't know if those are questions. Those are not questions, but we did get a Cash App, so let me make sure to read that. From Grimlock with the in production today, don't forget to hydrate. Fair enough. I will hydrate right now. I have hydrated. All right, cool. Read that book, didn't understand. Now I listen here, don't understand any of it. It's fun though. Well, I'm glad that you think so. From Philo Dragon with the $10, what do you think about the idea of our local universe deriving from something involving sans metric time? I've heard Linford and Schmidt talk about it, and I'm curious, would it make sense at all? Yeah, I think it does. I think that, like, there is a sense in which you can have emergent time from a non-temporal state. I think that that's something that is plausible. In fact, there was a paper that I read not a while ago, it was a few weeks ago, about this idea. It was an emergent universe idea. Let me see if I can pull it up. Is it this paper? Is it this paper? Maybe it's this one. Where is it? It's not this one. No, it's not that one, not that one. Not that one. I thought it was this one, but I remember the one that I remember looking at had a very nice picture, and I may have lost it. Yeah, I don't know where it went. Anyway, certainly, I think it's at least certainly plausible or possible. I don't know if it's plausible, but it's certainly possible. Let's bring up Rain. Rain, how's it going? Hello? I can hardly hear you. Rain?
Yeah.
Rain? Rain? All right, it looks like Rain's not here. Do you think we will one day discover subspace? I suspect not. I mean, it's science fiction, right? It's not real. Do I think that we will someday discover something like it? I also kind of suspect not, but who knows? I mean, subspace is supposed to be like below space in some sense, and who knows what that means? I certainly don't. All right, well, currently, actually, let me just double check. Oh, Will's back. Great. Welcome back, Will. You gotta unmute yourself.
Hey, Dr. Blitz, sorry about that.
You're good. What questions you got for me today?
So we talked last week, I think. I was asking about the U1, SU2, and SU3 groups, and you went into really deep detail about U1, but I kind of cut you off before you went to
Sure.
the same level of detail about SU2 and SU3. So I was just kind of wondering if you could kind of do the same type of explanation you did for U1 for those two.
I mean, there's not really much else to explain. All that you're doing is, so in the U1 case, you're gluing a certain kind of structure to every point in space-time. And it because U1 is like the topology of this structure is a circle. So you're gluing basically an extra dimension of like a circular space to every point in space-time. And then there's the curvature of the way that you kind of glue those circles together and how they're kind of, how one point on the circle is related to a point on a circle in the next one. SU2 and SU3 are the exact same thing. It's just a different structure that you're gluing to each point in space, or in space-time.
Oh, okay.
There's nothing that,
I mean, like,
it is more complicated because the kinds of motions that you can do in a circle, there's only one kind of motion. You can just go around and then you can do the reverse. On more complicated structures, the ones that you get from SU2 and SU3, they don't necessarily always commute with each other. So that's how you can get non-commutative objects. And these are called non-abelian gauge theories because they don't commute. But that's like kind of a technical detail that doesn't really affect the picture here.
Okay. So what do SU2 and SU3 represent in the standard model again? I can't remember. So
SU3 is the strong force. SU2 cross U1. Sorry. So it's really not SU2 is separate from U1. It's really that SU2 combined with U1 form the electroweak part of the standard model, and then that symmetry breaks down into something that looks like a U1 and something that looks like an SU2.
Okay.
But so yeah, that's in some sense SU2 is the weak nuclear force and U1 is electromagnetism and SU3 is the strong nuclear force.
Okay. And that kind of is all encompassing for the standard model.
Yep.
For all the forces. Okay. Well, that's really interesting. That's kind of the only question I had. I'm gonna definitely look more into that in terms of the topology and everything like that, since I find the math concepts really, really interesting. So, yeah, that's really all I had.
Sounds good. Well, thanks for being here, Will.
All right.
Take care. All right, y'all. I'm thinking I might end the live stream early because we currently have no sitting questions in chat. We have no guests in the queue. And also, I have to get ready for a graduation. One of my friends' offspring is graduating today, so I'm going to go support them. Chachi, thank you so much for the $5. It is very much appreciated. So I'm going to end the live stream here. I know it's a little bit early, or maybe it's a little bit late. But I will see you guys tomorrow for some more Ask a Physicist. Yeah, although I might be a little bit late because I'm going to the dentist tomorrow morning. So yeah, I'll see you guys tomorrow. Take care, everybody, and thank you for watching. Make sure to go check out my website, become a subscriber on Twitch, become a super fan on TikTok, become a member on YouTube if you want to support me.